Hello student, how are you? So today we will discuss about maxima and minima. Maxima and minima. So this is basically a mathematics topic, but still we will discuss in this in our physics group, because many times we face some problem related to some motions or some typical application problems which requires the maximum minima. Suppose you have been given a equation something like this. So S is equal to, let's say, 20t minus half 10t square. So do you remember what is this equation? This equation is exactly the same as ut minus half at square, no? So this is the motion equations. This is the motion equations, the distance covered in a particular time. So this is actually the equation of a stone throwing equation. I have taken it as an example. So this is actually the G. So under this gravity G, if a stone is throwing with the initial velocity of u, then it will move certain height and then reach again to the ground. So how much height it will, maximum height it will reach. So this is a maximum problem. Okay, so for a particular time, in a particular time, so if this is a time t and this is displacement s, then for a particular time it reaches a point that is a maximum point. So this way we can see many problems where we require this maxima and minima. So for maxima and minima, what you have to do, you have to follow the two-step process. So we have more elaborately the maximum minima. Every time the maximum minima can be present, it is not mandatory, because suppose the equation is something like this. If suppose this is x and a y, so equation is something like this. So here no maxima and minima is possible, because for every point of x, certain y value is continuously increasing. So this is called monotonically increasing or monotonically decreasing. So in this type of curve, you may not get the maximum minima. But the curve something like this, if a curve something like this, so here a minimum point exists, or a curve something like this, so here a maximum point can possible. Even you can get the more complex curve is something like this. So this type of curve is also possible in nature. So certain function is something like this. So in that case, this is the maximum and this is the minimum values. Okay. So we have cited over a simple example. This is the motion equations. There will find the maximum value by the method of maximum minima. By the method of that means mathematical tool maximum minima. Let's say how we will solve this problem by the maxima and minima. So maximum minima is basically I can say this is a two-step process. Two-step process means step one. Okay, you will be first given a function. Let's say the function of t. This is a t. This is the primary variable, independent variable, and this is the dependent variable. With this independent variable, the dependent variable is varying. When you change the time, then there will reach certain s, that means certain displacement change. So this is the primary or independent variable and this is the dependent variable. Generally, we keep the primary variable in this x-axis and dependent variable in the y-axis. If it is a function of t, then this is t and this is ft. If it is a function of x, suppose the value which is function of x, then this will be the x. Okay. Certain time we will encounter that some volume change with respect to the, let's say, temperature. In that case, this may be the temperature. Okay. So independent variable is temperature and the volume change, that is volume, is dependent on that temperature. So this we can say the volume is dependent on the temperature. So this way we actually represents the curve, but our focus is not in here. We just explain because we'll term this S as Ft. Okay, so it is better to understand. This is Ft. That is, Ft is basically the S, the displacement with respect to time. So in the S-axis, we can write this as Ft also, because Ft is dependent on T. Okay. So you have been given a function Ft. Okay. You have been given a function Ft. Then for maximum minima, the steps are, these are the steps. What are the steps? First step 1. Step 1, you have to differentiate this function. You have to differentiate the function with the primary variable. You have to differentiate this function with the primary variable and make it 0. Now this forms an equation. Now from this equation you will get certain values of t, maybe 1 value, 2 value, certain values you will get depending upon the equation nature. If the equation nature is first order, then you will get one solution. If the equation nature is second order, that means t square or something form, then you will get the value of two equations, solution of two equations. If this itself is a order of 3, then you will get the 3 values. So depending upon the nature, you will get the basically the values of t. When you are equating the differentiation of this function with 0, you will get the values of t. Now step 2. So here I have to say one thing more. That is the value you get. Let's say this is the t1 value and let's say this is the t2 value. Now we are pretty sure that there are a maximum or minimum in these values. There are a maximum or minimum in these values. But we are not sure whether in t1 value the maximum value present or minimum value present. We are not sure. We are not sure whether the maximum or minimum value present in this T1. Suppose this is the T1. This T1, at this T1, whether the maximum present or minimum present, that we are not sure. Whether in T2, whether maximum present or minimum present, that we are not sure. But we are sure that there must be either maximum or minimum in this point. There must be either maximum or minimum in this point. That is the main important in this first step. So we are pretty sure that in between these 2 points we have either maximum or minimum. So the second step is the deterministic step. That means in this point maximum value or minimum value, that we can find out from the second equation. That means that time what we will do in the second step, we will do the second order differentiation of the given function. That means we differentiate first time, we differentiate the second time. That means second time differentiation with respect to t. Now you will get the second time differentiation, and now put this, you will get the equation first. So you put this, you find out the second order function's value at t is equal to t1. Now put this value, t1 value over here. Now you will get some value. If this value is greater than 0, then you are sure their minimum value is present. Minimum value present at t is equal to t1. Mind well, if this is greater than 0, then the minimum value is present. If putting this value t1, the value becomes less than 0, then the maximum is present. Maximum is present on at t is equal to t1. That is the rule. So let's say we are differentiating this function. So our function, so this is the g. So our function here, ft function is what? Ft function is ut. Let's say the absolute. That is the, here u is the 20. The initial velocity is 20, and the 10 is the acceleration. Gravitational acceleration is 10. So we will take this equation. Okay. So ft is equal to how much? So differentiate this equation. We will get. So this will be 20, and this will be, so 10 by 2. That means 5. Sorry, this will be minus. So this is 5, and t square. Differentiation of t square is how much? 2t. Okay, so I have find out the f dash t. So f dash t has been find out. So this we can say that is ft. We will remove this s. S is not required. Let's say this is ft is equal to this. So I have differentiate this function with respect to t first time. So I got this equation. Now I make this f dash t to 0. So f dash t to 0 means, so f dash t, I will make this f dash t equate this with 0 and we will find out the points. So 20 minus that is 10t is equal to 0. So t is equal to basically 2. So I am pretty sure that t is, so here only one value has comes out. Only t comes out as a one value because this is the first order equation of t. If this is the second order, then two value may come. So it is the first order equation. The differential equation is first order, so one value has come. So I am pretty sure that in this t is equal to 2, either maximum or minimum is present. But I am not sure whether this is maximum or minimum. That we have to check from the second differentiation. So make it second differentiation. So now my first order, that means f dash t's function is this. So I have to again differentiate. So I should write this differentiate with respect to t. Now again differentiate with respect to t. Differentiate with respect to t. Again differentiating this with respect to t means f double dash t is equals to, the constant term differentiation is 0, we know, and this is minus 10t is there, so minus 10 is the constant. So t, so differentiation of t is what? 1. So now this is minus 10. Okay, so this f dash t becomes a function. So if we write this f double dash t, this becomes a function or equation is like what? A constant value, that is minus 10. So this is a typical equation. It could, if this function came something like this, say this function came as minus 10t plus 1 or something like that. In that case, if we put this value, the find out value, the t1 value, what we have to find out? T1 value is 2. So we may find out the value of f double dash t. So it is not viewable, na? So I should, okay. So I have to, okay, I have to write it over here. Huh? So I am erasing this thing. This is ft and okay. So ft, this is the form of this. So I am writing over here. So I have some space constant, so I have to write it. So my value comes out as f double dash t is equals to minus 10. Okay. So I have to put the value comes out over here. That value comes out. T value comes out is what? T is equal to 2. So let's say f dash t. Now I have to find out. I have to find out the f dash t when t is equal to 2. So here I can see there is no, this function is not the t dependent. So whether t value is 2 or 3 or anything else, this value is constant. So I have taken one example where the second differentiation is basically constant, but in real situation you may not get that things. You may get this function, that f double dash t function is also dependent on t. In that case, in that time, if you put this value t is equal to 2, in that case, in that time this may comes out to be either positive or negative. But here we can see in our example this is always negative. So the value, the negative, if it is negative, then maximum value is present. That means at t, that means if it is less than 2, so maximum value present. Maximum value present at t is equal to what? T is equal to 2. So at t is equal to 2, say this is the t is equal to 2, the maximum value is present. Then how much is the that means the maximum value? So the maximum value will be, so put this value, put this t is equal to 2 value in this equation. So f dash t, ft, so ft at t is equal to 2. So 20, put this 2 and a minus, minus. So this is minus half into 10 into t value is 2, so 2 square. So this will be 40 minus 20. Okay. So 20 is the maximum value. So this is the value, that this is the maximum value is 20, and t is equal to t1 is how much? T1 is 2. So we can say that at t is equal to t is equal to 2 seconds, the maximum value is been reached, and that maximum value is what? 20. So if we plot this graph, in that case you also see this. So you have noted these things. Okay. Now I am showing this, that whatever we have come to the conclusion, whether that is true or false, that I will check now. Okay. So if we plot our curve, let's say I'll take that t and that is ft. Okay, t versus ft plot. So if we put this is 0, so 0 is what? 0 and 0, that means this is 0. Okay. If we put 1, that is 20 into 1 means 20, and this is 5 into 1 square, that means 5. 5 into 1 square means 5, and this is 20. So this becomes 15. Am I right? Is it? And if the value is 2, then 2 into 20. 20 into 2 means what? 40 minus this is 5. 10 by 2, 5 into, that means 2 square. 2 square means 4. So this will be 40 minus 20. So this is 20. So at 2 the value is 20. Okay. Now let it be 3. See how the value is. So at t is equal to 3. So t is equal to 3 means this value will be 3 and this value will be 3. So 20 into 3, that means this is 60. Okay, this is 60, and this is 5 into 3. 5 into 3 square. So this will be 5 into 3 square. So earlier it was 2, so this was 4. No? Earlier this was 4. Yes, 4. So 5 into 4 means 20, and this was 20. So this was 20. It's okay. So now this is 20 into 3 and 5 into 3 square. The value, t value is 3. So 3 square. So this is 60 minus 9 into 5. That means 45. So my net ft will be how much? 15. So at t also you can find this is 15. So at 4, what it will be? At 4, so this will be 4. So 20 into 4 means this is 80, and 4 square means 16 into 5. 16 into 5 means again 80. So at 4, at time 4, time t is equal to 4, the value is again 0. That means you can see that at t is equal to 0, let's say this is t and this is ft, or let's say this is the s. ft you can see that is ft is the s, the displacement. So at t is equal to 0, the s is equal to 0. So 0, 0 point. At t is equal to 1, s is equal to 15. So t is equal to 1, at t is equal to 1, let's say, so this is 0, if t is equal to 1, so t is equal to 1, the value will be 15. Let's say 1, 2, 3, 4, 5, this is a huge number you have to go. So let's say I am taking, this is the 15, okay. So this is the value 15, okay. Now at t is equal to 2, at t is equal to 2, t value is 2, t is equal to 2, the value will be 20. So if this is 15, 5, 10, 15, 20. So proportionately this will be here. Okay. So this value will be how much? 20. This value is 15. Now again at t is equal to 3, we will get the 15. That means at t is equal to 3, we will get the value again this. At t is equal to 4, your value will be again 0. That means 0. At t is equal to 0, it is 0. T is equal to 4 is 0. You can find a t is equal to 5 also. T is equal to 5 will be how much? T is equal to 5. And here the 5. That means 5 into 20 means this will be 100. Okay. And this 5 multiplied by 5, 25 multiplied by 5, 125. Okay. So 125. Here your value comes out as a negative 25. So when you further reach, that means 5. So that time your ft value will be negative. That means if this is your 20, this will be much over here, much bottom. So let's say this is something like this. So your curve is something like this, moving like this, moving like this. So we can see that this is the maximum value, is it? This is the maximum. Nowhere this is the maximum. The value nowhere reaches more than 20. So 20 is the maximum value. We have find out also this is the 20 is the maximum value. Understood? So 20 is the maximum value. And what is the point where that maximum value is present? The point is t is equal to 2. That t is equal to 2. You can see from here. So at t is equal to 2, the maximum value is reached in this equation. Apart from these two value, no other point is crossing that 20. That means here this is the maximum. So what I have taught here, that is the maximum value. I have represented the maximum value in the form of graphical representation. The maximum value reaches at t is equal to 2 and the maximum value is 20. So at t is equal to 2, the maximum value is 20. But this can be solved by the two-step differentiation. First step differentiation, find the t's value for which that equation becomes 0, and then those values you put in the second order differentiation. There you will find whether that is maximum or minimum. So that way you can find out the points where the maximum value and minimum value is present. And once you are sure about that, the point has been determined for the maximum, then put that point in the equation. Put that point in the equation in your original equation and find that maximum value or minimum value. So students, I hope you have understand this point, and for stay with our video that why this first order differentiation and second order differentiation behave like this. Why this is the maximum point. Maximum point is here and minimum point is here. To find out why we differentiate the first order and then to check that whether the maximum or minimum is present by this deterministic equation is the second order. To know that, you have to wait for the next video. In next video, I will come with the detailed analysis of maximum minimum. Stay with us. If you like this video, subscribe me. Okay. So for that, well done. Thank you.